In this video, we will discuss points where graphs change behavior. There are two places a graph can change behavior, a critical point or an undefined point. Before we define critical and undefined points, let's recall what a derivative means. The derivative is the instantaneous rate of change of a function with respect to one of its variables. Most commonly with respect to x, when a function is defined by f of x. It is also known as the slope of the tangent line to the function at a given point.
Okay, so what is a critical point?
Good question. The points on a function where the derivative is 0 are called critical points of the function. A critical point of a function will exist at the point or points at which the first derivative is equal to 0. This means that the instantaneous slope of the original function must be 0 at the place where a critical point exists. We will keep in mind that when the first derivative is 0, the function may change from increasing to decreasing or from decreasing to increasing. Since we have learned in previous lessons that the first derivative is the same as the slope of the tangent line at the point of tangency, we know that a tangent line at the critical point will have a slope 0. In other words, the tangent line at the point of tangency is horizontal and of the form y equals c, where c is a constant and equal to 0. For example, let's analyze the function f of x equals x squared graphically and analytically. By using the graphical approach, we can see that the function decreases until it reaches a critical point at x equals 0, where it then begins to increase. The critical point exists where the function stops decreasing and begins increasing. We can also use the analytical approach to find the critical point, meaning we will use calculus. Using the power rule, we can take the first derivative of f of x equals x squared to get f prime of x equals 2x. We can then determine where the first derivative is equal to 0 by setting 2x equal to 0 and solving for x. Once we do this, we will get that x equals 0. Notice also that the graph of the derivative of the function at x equals 0 is equal to 0 and is tangent to the function at the point x equals 0.
Can a function's derivative be equal to 0 at a point where the graph does not change from increasing to decreasing or from decreasing to increasing?
Yes, it can. It is important to note that a function's derivative may be 0 at a place where the graph does not change behaviors.
Can I see an example of this?
Of course, an example of this would be at the point where x equals 0 on the function f of x equals x cubed. Looking at the graph, we can see that the function is increasing to the point 0, 0, where it then begins to increase again. However, if we take the derivative of f of x equals x cubed to get f of x equals 3x squared and set 3x squared equal to 0, then solve for x, we get that the derivative of the function is equal to 0 at x equals 0. Therefore, this is a case where the derivative of the function is equal to 0 but is not an extremum point. This point cannot be an extremum because the function does not change from increasing to decreasing or decreasing to increasing. So, even though the derivative of the function is equal to 0, the graph does not change directions at the point.
Okay, I understand. What about undefined points? What are those?
Undefined points are points where the original function and first derivative are undefined. If the original function is undefined at a point, the first derivative will also be undefined at that point. So you can use either the original function or the first derivative to determine the points where the function is undefined.
Does the graph behavior change at an undefined point?
Yes, just like with critical points, the graph's behavior must change at the undefined point for the point to be considered significant. However, it is possible for points where the original function and derivative are undefined that the graph does not change behavior.
Why are undefined points not the same thing as critical points if they follow the same rules?
Great question. All critical points must be in the domain of the function. If a point is not in the domain of the function, then it cannot be a critical point. Since an undefined point does not exist in the domain of a function, it cannot be a critical point. For example, we will look at the function f of x equals x divided by x minus 3. We know that the denominator of a fraction can never equal 0. Now we set x minus 3 equal to 0 and solve to find that x equals 3. Now we know that in our example, f of x can never equal 3. You may want to review asymptotes of rational functions to find that x equals 3 is an asymptote of f of x equals x over x minus 3. Additionally, because the function is undefined at x equals 3, the first derivative will be undefined at that point. The first derivative of f of x equals x divided by x minus 3 is f prime of x equals negative 3 divided by x minus 3 squared. So we can see that the first derivative is also undefined at x equals 3. This is helpful because you do not have to take the derivative of the function to find the undefined points.